This question asks, how many grams of sulfur trioxide are produced when 20.2 grams of iron 4 oxide reacts with excess oxygen? So the excess oxygen just means we're not going to worry about this. We're only talking about this and this. So let's list the first let's check and make sure it's balanced. Again, I told you if it has coefficients, it probably is, but it's a good idea to make sure. So we have 4 iron here, and 2 times 2 is 4 iron here. 4 times 2 is 8 sulfur, and 8 sulfur. 15 times 2 is 30 oxygen. So we have 8 times 3 is 24, plus 2 times 3 is 6. That gives you 30 oxygen. So this is balanced. So in order to go from the grams of FeS2 to moles, we're going to have to use 1 mole equals molar mass. And so we have 2 sulfurs, and each sulfur is 32.06, and 1 iron, and that's 55.85. So our molar mass is 119.97. We're also going to have to use 1 mole of SO3 equals the molar mass of SO3. So 16 times 3 plus 32.06 gives you 80.06 grams of SO3. And now we need our mole ratio to relate FeS2 and SO3. So FeS2 and SO3. For every 4 moles of FeS2 that react, 8 moles of SO3 are formed. Now all that's left is the dimensional analysis. So we have 20.2 grams of SeS2. And to get those grams to cancel out, we have to have grams on the bottom. We have to use one of our conversion factors. And that equals 1 mole of FeS2. So the grams cancel out. And we get 0.168375. moles of iron 4 sulfide. So now we're going to use our mole ratio to go from moles of FeS2 to moles of SO3. We want to cancel out moles of FeS2, so we look at our conversion factor. We have 4 moles of FeS2 and 8 moles of SO3. So in this case, we have to multiply by 8 and divide by 4. So times 8 divided by 4. And that will give you 0.336751 moles of SO3. And the last step is to turn that moles into grams. So we know we have 1 mole of SO3 equals 80.06 grams of SO3. And moles cancel out. And you get 26.9603. So when we look back at significant figures, we have 3, 5, and 4. So when we round our answer to have 3 significant figures, we get 27.0 grams of SO3.